Humans started working and developing agriculture about 10,000 years ago. People have hybridized plants to make new crops, and they were eventually able to recognize that you could make crosses of different strains within the same species.
All crop modifications fundamentally depend on mutations, right? Mutations in DNA, which turn the crop into something different, whether it's a seedless watermelon or a high-yielding form of wheat or something.
More recently, of course, is the genetic engineering process. You can identify a unique gene, you can reconstruct that gene, and you can introduce it into a host plant.
People have this horror of the transgenic approach. My God, you're taking a gene from a fish and putting it into a strawberry. I mean, that's a mythological example, but that's the one that often gets referred to. As if that would somehow take essence of fishiness into a strawberry, but it doesn't. It's just a DNA sequence. It might just code for a protein. It's got nothing to do with the essence of the species.
It's easy to develop this fear that somehow you've mixed large amounts of genetic information and you've created something totally different. Again, nothing could be further from the truth. You're not taking a gene out of an insect and putting it into a plant. You're actually understanding genetic information, and you're synthesizing a gene, in fact, that you can then introduce into a plant. So you're not borrowing a gene from something and putting it into a plant. You're looking at that other system to understand what the mechanisms of resistance are, or the mechanisms for producing more oil or some beneficial trait, and then you use that genetic information to create or synthesize a genetic construct, if you will, that you can introduce into a plant. So we want to make it very clear that this is very precisely done, it's reproducible, and it's not done in a random way where you're taking genes randomly out of an organism and somehow packaging them to another organism. Well, there's certainly concern about modern genetic technologies and the use of genetically modified or genetically engineered crops. The concern is that somehow they're not safe. There's new variables introduced. Maybe there's new allergens or toxic products in these plants, that they haven't been adequately tested. In fact, nothing could be further from the truth. These plants have undergone very thorough, confined field testing to make sure that there are no safety issues, no environmental issues with them whatsoever. There is a series of steps that the regulators impose on researchers before you can come to a product that's commercialized. This takes years, though there's very, very sophisticated and detailed testing. There is no concern about safety of these plants. There have been literally thousands of research publications supporting the fact that these products are indeed very safe.
The way that science works is in building up a weight of objective evidence based on observations or on experimentations or whatever. So there's no single scientific paper which should change your mind about things. That would be a misunderstanding of the scientific method. What matters is the hundreds upon hundreds upon hundreds of papers which have been written by scientists showing that there's no evidence of harm. To be a good scientist, you have to emphasize uncertainty, objectivity, the provisional nature of your data. Now, those don't make effective storylines. And so you can misinform 1 million people using YouTube much more quickly and much more easily than some expert can come back and tell them the truth. The word viral is used for a reason, and misinformation can spread virally, and it can infect people in very large numbers. I see genetic modification and GMOs as aiming to achieve the same objectives as agroecological or even organic farming. As an organic farmer trying to grow potatoes, one of your biggest problems is blight, right? Organic farmers often use copper sulfate, which is not good for the environment, to control blight. Now, if you can develop, as has already been done, a blight-resistant potato by incorporating a blight resistance gene into conventional potato varieties, why isn't that organic? You can give up the copper sulfate, you can just allow the biology of the potato to protect itself against the pathogen. But you can only do that using genetic modification. You can't do it using conventional breeding. Or perhaps you could, but it would take 30 years rather than 3.
Certainly there is concern not only by producers but the general public about how sustainable our food supply is and how long we can rely on the health of our soil and the kind of crops we produce from that. But in fact, new technologies, including genetically modified technologies and the use of agricultural chemicals used carefully and appropriately, has actually greatly improved soil health and soil quality. The use of these technologies has allowed farmers here to go to continuous cropping, which is a phenomenal development. We're not dealing with those terrible dust storms we used to have when we had to summer fallow because we couldn't use continuous cropping methods.
The efficiency with which you use land is a really important environmental metric. If you can get the maximum yield from the smallest area of land, then you can spare a much larger area for the rainforest and for wetlands and for other areas of habitat which are really important for natural species. If, on the other hand, the whole world has to go organic and go back to using, old technologies from the 1950s, then we'd have to double the area of land which we're ploughing up, which would mean destroying the rainforest and so on. And nobody gets this, right? Everyone thinks that organic is better for the environment, but because it's less productive, because by definition it uses more land, that's actually a much worse issue if you're concerned about biodiversity and conservation.
There's a good news story out there that very few people appreciate, that these methods of production have actually restored millions of tons of carbon into the soil. In other words, we've contributed to the problems of climate change by capturing carbon dioxide from the environment and trapping it in the soil. So we have actually increased the amount of carbon in our prairie soils tremendously. It's not well appreciated. So I feel very positive about the sustainability of our agricultural systems using these new technologies.
The real concerns of food security in developing countries, where around 800 million people still are malnourished because they don't have access to sufficient food resources, that's not really part of this conversation. The insect-resistant crops, which have been bred using biotechnology, and BT is a great example, allow farmers to reduce their use of insecticide. Now that's a good thing for sustainable agriculture because you have less chemical pollution on the land. Drought tolerance technology, that's good for farmers in developing countries who don't have irrigation, better for responding to climate change. Nitrogen use efficiency, use less fertilizer. Biotechnology is vitally important for agriculture because it enables us to have a more sustainable and a healthier food supply. It's really that simple.
Golden rice is an excellent example of a GM crop that has direct human health benefits. We all know, of course, rice is generally consumed as a white rice, and it's consumed that way in many parts of the world, including the tropics. As a result of heavy rice diets in that part of the world, many of these people are very short of vitamin A, and this results in very serious health problems such as night blindness. It really is the cause of terrible diseases and many deaths. And golden rice has been developed through GM technology. It's been clearly demonstrated that consumption of that rice will alleviate any problems associated with vitamin A deficiency. So unfortunately, that rice has not been released commercially, even though it has been developed about 12 years ago for commercial release, simply because of the fear-mongering and the activist concerns. It's really a tragedy, and some researchers claim it's a crime against humanity to have denied that product to so many millions of people that could use it.
I read the comments underneath my last anti-GMO article in The Guardian, which is still available online. And I just received the prize for my book on climate change from the Royal Society for the best science book of 2008. And yet underneath my anti-GMO article, people were pointing out that I didn't know what the hell I was talking about and that I had no scientific evidence to back up what I was saying. And that really wounded me as somebody who prided myself as a science communicator. And that's when I realized, right, the first thing I have to do is shut up. The second thing I have to do is go back to basics and do some reading. And that's what changed my mind, was seeing statements from the best scientific academies in the world saying there is no evidence for harm of GMOs and the use of modern molecular techniques of biotechnology is safe. Very unambiguous language, and exactly the same sort of language that I was always pointing to when I was defending climate change research in the face of climate change skeptics. And so I couldn't sit there and say, you must listen to the voice of science on climate change, and you must ignore the voice of science on GMOs. I don't regret being honest about my change of heart and my change of mind. If anything, I regret the damage that I've done in the world by helping to hold back this technology. Kind of the way I see my role now is almost to make redress, to make amends for that, which is why I'm doing a lot now to promote the use of biotechnology.
Well, I'm a plant scientist, and plants are the foundation for civilization. We wouldn't exist without green plants. And there are so many exciting aspects about plant biology, and better products, higher yields, better environmental conditions. I think it's a great area to have a career in.
The family farm, a tradition in Canada going back 200 years. This canola farm has been in the family for 3 generations. Today's farmers face the same challenges as their forefathers: weather, soil fertility, pests, commodity prices. But today's farm is radically different from the romantic ideal.